All right, so here's your stupid, random, useless fact about Rutherford. His first name is that. Isn't that just kind of a little bit funny? Because usually you think of like Ernest. I, I think he was he German maybe? Probably German. Why not just name him Chris? That's a great question. Okay. All right, guys, come on. Here, so first thing I want you to notice here is once again, we've been looking at the timing, right? And how the cutting cheese experiment was a heck of a pretty good experiment, right? Like that got us through a lot of history. And then things started to speed up a little bit. We had some major things being learned in the 1800s. Late in the 1800s, J.J. Thomson made this smashing discovery that the atom was actually not the smallest thing in the world, okay? Because there was an electron. And then now, 1911, so just what? That's 14 years later, right? Not very much later. This dude did an experiment called the gold foil experiment. Do you know what gold foil is? It's kind of like aluminum foil, except it's made of gold, right? And so what he did was he took this like sheet of foil and like wrapped it around in a circle. So like imagine you're like looking down on it in my little picture here. Okay. He made this little circle out of it. And then he took a machine and he shot particles at it. And so there had been a lot of discussion in the recent years. Can you guys see okay?
It looks like you made a face.
It does kind of look like that, doesn't it? So in recent years, people have been doing a lot of experiments with these things they called alpha particles, and they didn't know a whole lot more about them really. But what he did was this machine shot what they called the alpha particles at the foil. Okay? So what I want you to picture is shooting like a squirt gun at a fence. You know, like at a chain link fence. Okay? And what happens to the water when it hits the fence? It splatters everywhere. Does it all splatter everywhere?
No,
Some goes straight through, right? So that's exactly what happened here. But how many of you guys know gold foil, just like aluminum foil, is solid?
Yeah, because you can like smush it together.
It's like, well, but even so, like you can't see through it. It's like aluminum foil, you guys. It's solid. It's probably thinner. They use gold foil for experiments like this because you know how gold is like soft. Well, you can pound it thinner than a lot of other metals, and so that's kind of why they choose gold for this. But the important thing is it seems solid to your eyeball. Ernst Rutherford would look at this and go, "This thing is solid." But then when he shot the particles at it, they behaved just like water going through a chain link fence. Some of it went straight through, okay? Some of it like bounced off at all kinds of awkward angles. Some of it bounced off like in the backwards angle, right? And sometimes they like got literally bounced like straight back again, like all over the place, totally across the board. Does that make sense?
Yeah.
Just like when you start squirt water at a squirt gun, right, at a chain link fence, okay? Let's write that down now. So alpha particles shot at the foil. But what he actually discovered was that the amount of the particles that went straight through was the most. Like some have bounced off and so forth, but more of them went straight through than anything else. So most went straight through. Okay? So some were what we call deflected, which means they like bounced off and went slightly crooked. Okay? Like these two arrows here. Those two. That'd be like that one. Okay? And some bounced back. And this was like the most confusing thing to them because do you remember they're operating under the assumption that the atom is solid, right? Because what was this previous one here, the atom is a solid positive sphere and it has negative chunks floating around inside it. And so then this happens, this experiment, and says, wait a second, why is stuff going through something that we thought was solid? You'd be asking that question, right? If you thought your fence was solid and then all of a sudden you start squirting water through it and the neighbor still gets wet, right?
Yeah.
So that'd be confusing. So this is what he kind of decided. He also, I should have probably mentioned this, the alpha particles have a positive charge, okay? That probably matters for fully understanding this. But the positive mass is the thing that actually makes the alpha particles bounce. Oops, that's a K, all right? And then the other thing is that this positive mass, this is number 2, okay, was located in the center of the atom. Okay? And then his third thing was that he changed that plum pudding model and he said, actually, the electrons are not just floating around in a solid sphere, but they are circulating, or electrons circulate in empty space around the nucleus. Making sense?
Yeah.
So then he, of course, needed to make a new model for the atom. And now I will tell you a really funny story about an argument I had with some other teachers at Penn. This happened, I think maybe 2 years ago. And we had always kind of had a little bit of disagreement about what this model was called, and especially comparing it to the next one that we're going to do in a second. But finally, there was one day we had like kind of a heated argument about being like, well, no, this is what this is called. And the other person goes, no, you're wrong. It's called this other thing. So finally, I took the initiative to actually look it up online and find out why are we having this a disagreement? And it turns out that actually a lot of people disagree about what these models should be called. Because think about it. Do you notice the date here and the date here? It changed so fast at this point in history that who really cares what they're called? You know what I mean? This is not significant. Dalton's model, his model was good for 100 years. Who cared, right? Democritus's model, that was good for so long, right? But this doesn't matter, right? But so I'm just going to kind of give you a couple of different I'm going to just give you a couple of different names here so you'll kind of know that that's the case, and just know that we will never make a test question that's confusing, okay? We'll always make sure it works out okay in the test question. Some people call his model the planetary model because the electrons go around like a planet, okay? But then this one over here also gets called the planetary sometimes. You can go ahead and put that down there.
What do you call it?
Okay. Some people also call this one the electron cloud. Because just think about it. If the nucleus is in the middle right here, then what do the electrons do? They circulate in empty space around the nucleus. You see how this makes a cloud? Okay. So that's why some people call it that. But then this ends up being, I think that's what I put on your practice quiz. But this ends up being not very helpful because in the model that came after our notes that we're not even going to talk about it because it's based on mathematics that's so complicated that you guys haven't learned it yet. Actually, I never learned it. Okay. So that name kind of comes back later in history. So this ends up not being awesome. The third name that, just to put it out here, is called the central nucleus. Okay, so all three of those are decent names for this, and you just kind of have to realize there's some disagreement going on here. Yeah.
What do you call it?
I used to call it the planetary model, but then I realized that this was a confusion that was just a problem, and then I put in your practice quiz electron cloud, thinking that was going to be better, and then this came up, and so you need to just like sort of see them all, and you'll be okay. Okay. So here we go. This right here is the nucleus, and it has protons in it. Okay? Sound good? And then these things here are electrons going fast. Sound good? Yeah. All right, so what's important still today? The idea that the nucleus is in the center and that it's small, that's really important still today, right?
And then electrons float around the nucleus.
Yeah, the location of the electrons around the nucleus. But the thing that's really not important is this chaos idea. Is that good? So the idea that the electrons are simply traveling in a chaos pattern around the nucleus is very much not correct anymore. We now have more specific things that we know about where the electrons are located. And we'll talk about that in a second.